because I forgot to even do this last hour. What I was looking for here is just what are the basics for sine and cosine. And notice what I put over here. The period of the parent is 2 pi. But anything below this, it's 2 pi over whatever b is, and then it's up to you to cut it into fourths. And then that's the big thing, just knowing your fractions or not. So hopefully we do well with that. I'll leave my ugly face there just to prove I'm in class and I got my mask on and all this other stuff. So sine's 2 bowls, and then A is whatever the amplitude is. You just stick those values there. So this is what we were looking up at the top. This is what you should know about sine. Looks like 2 bowls. And this is what we can expect to see. So almost everything on this page will look the same, but it's all about the x-axis values and the y-axis values. So I've had people, let's not insult, but for the love of dog, this is the whole idea. You got to have all those marked. That's the whole point of this worksheet. So you got to find the period and then cut them into fourths. And then it's all about what are those x values. So just make sure you know that. Then for the cosine kid, it starts high, down to 0, down to low, down to 0, or back up to 0, and then up to high. Cosine kid. So anything that's a cosine will probably look like that unless it's flipped over the x-axis. Be careful on that as well. Seeing those negatives and that happens. That's not what I'm here for, though. What I'm here for is you should know how to do this now. And sorry about my numbering. I think my numbering is all jacked up on this worksheet. Oh, yours says 7, 8, 9. I think it's okay. 10, 11, 12, 13. Then there's another 13. I can't number. Sorry. Okay, but let's look at 10 real quick. And I'm going to have you do stuff today, so be ready. I'm going to call out your name, and it's going to happen. So, but maybe not right now. Everyone, what do I see right now? What is that? Is it sine or cosine, first of all? We better all say it's cosine. I just did it on the last page. This is a cosine kid. So this is like 1 point. This is what you're ultimately doing. What's the equation? This might be a second point. What's the amplitude? 4. Be careful on number 11. It's a little bit off. And it's not upside down. So there is no negative needed. All right. Okay. Now what's the period? The period is the x-axis that one complete cosine kid is completed. So what is that period? Pi. It's an x-axis distance. Now remember, period comes from 2 pi over b. And you probably could figure out what b is then. What's b? 2 pi over what equals pi? 2 pi over what number equals pi? Come on. 2. We already know that. But then that hammers down the point that the period, wrong, that the b value comes from, you could switch these two like I showed you in the video yesterday. Well, it wasn't a video, but it was me, but it looks like a video when I'm online with you. And the period is pi. So either way, we know that b is 2. So that is the equation from that graph. So another nice breakdown from what I covered yesterday. Should be fine with all the rest of these. Make sure you just understand what you see, and then understand what the period and amplitude is. Real quick, because we ain't got much time. Not necessarily. You really got to break it down and just locate one complete either sine or cosine, and then just ignore the rest. Okay, are you saying like this? You see 2 cosine kids up to 2 pi? Is that what you're saying? That would be okay, because that is another meaning of that 2. So tread lightly. Be careful on that, okay? Because this is the definite mathematical way that will always work. I could just imagine some questions where it doesn't perfectly show up the way you're asking or the way you're expressing it. Okay, I want you to make a change on the second 13. Ignore that we want it from 0 to 2 pi. We want where all of these occur, all maximums, all minimums, and all zeros, because I'm going to show you something that will definitely translate to what we'll do in chapter 6, which is a long ways away, but I don't care. So yet again, everybody, let's pick a better color. What do I see on this starting at 0 to here? What is that a picture of? Sine or cosine? I know they don't ask that, but it's good to go through it. That's a sine. So what's the period? What's the x-axis distance? Everyone? This is why I call on students, because a lot of people don't answer during everyone things. It's 2 pi. And then what's the amplitude yet again? 4. So fine, we had to fill out those things. That's it. Those are just the answers for that. But now notice what it says in the directions. Identify where the maximum value occurs. Not what, where. And we had this before in another chapter back in the first semester. Where means the x coordinate that makes it happen. What is the maximum is obviously 4. And notice that this happens not just twice, forever, because this graph keeps doing this wave backwards and forwards. So I have a forever, a bunch of maximum where they occur. First of all, what is the first x value that makes this happen? What is that right here? What is that? You can almost see me. Ooh, I like doing this double. The screen's too bright though. Cool. What is that? That's pi over 2. We should know that because that was the original, family or the original parent. When the period's 2 pi, half of 2 pi is pi, half of pi is pi over 2. Now, I have a quick question for you. How far away is the next one? And then the next one, then the next one. So what is this distance from here to here? Because this is going to give us a way to express all the answers. What's the answer to that? It is 2 pi. All right, that is actually a period away. As a matter of fact, you can count it as a 2 pi. And I did say this about sine and cosine. From this interval to that interval, doesn't that look like a cosine kid? Because that's all sine and cosine are. They're the same thing, but they're just shifted a little bit. All right, and so that is 2 pi. So what do I do about that? I'm going to write this one time and then explain what n is. N is an integer, any integer. Sometimes books use Z. I think Z is the letter for integers when they denote that family of numbers. But usually what we write comma, n is an element of integers. So what is an integer? 0, 1, 2, 3, -1, -2, -3, even the other way. So when I plug in 0 for n, I get this first one. Try to get out of the way of myself. When I plug in 1, that generates this one. This is a generator for all of these locations where I have a maximum. When I plug in -1, I get the one back here that's about to occur. When I plug in 2, that's 2 away from this one. That's the one that's going to occur out there, and so on and so on and so forth. It's a generator of all these positions. Good on that. Where does the minimum occur? Well, what's this one right here? This is obviously the minimum. What is this x value? 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2? Yes. So 3 pi over 2 is right. And then it's the same thing. Just to speed this up, they are also 2 pi over n, or 2 pi n away. Sorry. We don't always have to say n as an integer. All right? You're going to have to do this in 2 chapters. This whole, what are all of the answers for a solution of a trig function? We're going to have to tack on that little element there. Okay, so it's good to go over it right now. And then the last thing, zeros. Be careful. Zeros are here. My question is, how far are all the zeros away? A little different. How far are the zeros away from each other? What's this distance from here to here? Here to here? Here to here? It's only pi. What's the first one? Actually, 0. I wouldn't be mad if you wrote 0 is the first one, and all the other ones are pi away. But really, you don't need the 0 written. You just say 0 plus pi n. Okay? All right. So I'm done with that. We should be able to do this those last 3, and I apologize for my numbering issues. Now we're getting into this. And actually, I had an ugly set of notes from the past, and I'm sick of them. So I wanted to get a nice, clean typed. So I used a worksheet generator just to get some of our examples today. And really, you're going to be doing what I'm doing. So go ahead and get your standard notes out. And this is what we're going to do. And we're also going to sketch the graph. This is a little bit of a challenge. I'm not going to be a liar on this. This one, you're lucky, and good that you're here so that we can do the best we can on a tougher concept. And I will say, probably in the first one, I'll talk about 2 cycles or 2 graphs of it. But whenever we start incorporating right-left shifts, and because of the less time that we have together, I think we're going to stick to the test of just doing one graph, one cycle. Because when we move right and left, this is tough, really tough. So these are just the things that you're going to do. You're going to find the amplitude period. This is what I'm going to walk around the room. All right. Phase shift. What? Never heard of that word in my life. I don't know why they come up with this word. I've used it for 25 years. Why they call it a phase shift, I don't know. And then a vertical shift. And I think you can see from this equation, you should know what everything is. Like, for instance, what's the A, everybody? What's that called? It even starts with an A. Come on, use the word. Amplitude. Okay, what does the B determine? What does the B determine? The period. Good. So B determines the period, but just make sure that's not the period. The period is 2 pi over B. You do have to do some stuff. So that's not just the period, that B value. It determines the period. What's the minus C? You got to remember this from first semester. What does minus C do? Does that go right, left, or is it up, down? Which one is that from last semester? It's a right, left. Last hour kind of got that wrong, at least the ones that answered. It's okay to answer and be wrong. It just gives me a little assessment of where you're at as well. You know what that's called, though? That's called the phase shift. I don't know why they call a right-left shift a phase shift. I probably should have looked that up, and I probably did in the past and didn't like my answer. I'm like, okay, fine. For trigonometry, right-left shifts shall now be called phase shifts, just so you know that. And then, of course, D is an up-down. And I did show you that a little bit yesterday by grabbing a graph and just moving it and showing you how it's not that hard. Okay, so my first example, I did keep it simple because this is the hardest thing. I probably should have put an up-down shift with it as well, but we didn't, so it's not a big deal. Okay, so Muhammad, what is the amplitude? So I just want to make sure we're, assessing these correctly and get correct numbers and mark our axes correctly. It is 1, okay, because I don't see anything. Alexander, you have a tougher question. Last hour was like, oh, what's the period of this function? I'm going to point where you should be looking. I don't see anything there. So what's that number that's invisible right there? 1, but period is 2 pi over B. So what's 2 pi over 1? Yeah, so never put that the period's 1. The period is 2 pi over whatever B is. And then, of course, that's 1. So we'll just, that's 2 pi. And then Natalie, what is pi over 4 called? What's our new math word of the day? Which way is this phase shift? Is it right or left? Nicely done. I didn't tell you a thing. You recalled that on the inside, minus means right. It's like opposite. I always said that back in the day when we were shifting just functions. You think opposite here and same here, meaning minus is left on the x-axis, but actually you go right. On the outside, when it's plus a number, it is a man. Are you almost done with that drink? You've taken like 74 drinks during these notes so far. There used to be a rule, not no drinking in class. I used to be the water jerk. You're just a jerk in general, Mr. Samuelis. Now, anyway, he's and then there's no up-down shift, so we're good to go. Here's what you do, though. Please trust me that this is a bit of a challenge. I'm going to try to make your life easier. Normally, what you would go do, there's another drink. That's your last one. Okay, take that drink, put it down, and then put your thing back on. 75 drinks. Okay, good. Now put that away. The bottle's like this big. Usually you would go 0 to 2 pi and then cut it into fourths. But then everything gets phase shifted pi over 4 to the right. And then that gets real messy on the x-axis. So this is what you should do. You should take your period off to the side and do your side work over here. Break down the period into fourths, then phase shift those x values, then put them on the coordinate plane, or else you're causing yourself a major problem. Trust me. So Sarah, this is actually our parent function. So what we did was take half of 2 pi. What's half of 2 pi? And then what's half of pi? Okay, then listen to what I say. You probably already got it, and we already wrote it before, but 1 pi over 2, 2 pi over 2. Huh? What's that one? And then is this one 4 pi over 2? Yes, so we know 3 pi over 2 is. I always do the fourth one just to make sure I'm doing my math right. And then Aiden, this is weird. We have to move all of these pi over 4 to the right. So what does that mean I have to do? Add or subtract pi over 4 to these? Isn't that weird? It's minus here, which means pi over 4 right, but that means we have to add pi over 4 to all these. So absolutely. And then here's where the problem is. Again, this is why you hated radians in chapter 3. It's all fraction work. Aiden, I'm going to have you do the first two. Great. Well, don't complain about the first one. What's 0 plus pi over 4? Okay, now it's the next one. Aiden, if you say pi over 6, get out. It's not how you add fractions. What do you need to add fractions? I'm going to go ahead and do that work for you. You tell me when I get a common denominator, what this becomes when you add these two. 3 pi over 4 is correct. Let's move on to Robert. Common denominator is 4. So I have to multiply this by 4 pi over 4. This is why I write them here. Just takes a little elbow grease, and once you get this done, it's easy. And then after this, Robert, you might see a pattern in these and stop the adding. Keep going. Boom, 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 boom. A pattern develops because these are all equidistant. That's what we do as mathematicians. This what's this called? Face mask keeps jabbing me in the eyeballs. You ever had that happen? Is it just me? Okay. Keeps moving up and then hitting my eyeballs. I don't like it. Okay, and then now we go to the exit. Now I'm going to tell you, this one is actually not too bad to do 2 cycles. So I'm going to do 2 cycles on this, even though I said you won't be responsible for it. Just don't think I want to get you in that. I want you to be able to move them right. I want you to be able to see this work here and then just get a good graph there. Okay, so here's what I want you to understand. Pi over 4. These are still pi over 2 away. So do understand that. The distance between all of these stayed the same, pi over 2. So pi over 4 is smaller than pi over 2. So this is what I would appreciate, those that really go above and beyond. As a matter of fact, if you were going to continue this in college, it'd probably be an expectation. So I'm going to make this small. And then for the next value, I'm going to double the distance because it is twice as far as that distance I just denoted there. And I hope you understand that. Pi over 4 is half as large as pi over 2, and these are all pi over 2 away from each other. So here's where 3 pi over 4 is. The reason I'm doing this above is I don't want these x values to be in the way of the graph itself. Let's speed this up. 5 pi over 4. Come on, pen. 7 pi over 4. No time today. And 9 pi over 4. And I would appreciate that you have it at least like the distances look. I'm not going to get a ruler out. I'm not that much of a jerk. But then I am going to ask you this. And who is next? Robert just went. So we are with, almost said Abigail. Skylar. Oh, Abigail today. How does sine start? Now, this is the new starting point. And I wish I had more. I get this all tangled up. I can't go over here with this thing on. But you're starting here, not here now. It's moved. How does sine start? 0, high point, or low point? How does sine start? That's actually, that's the cosine kid. So how does sine start? Does it start at a 0, low point, or high point? Not high. So where does it actually start? 0. Sine is 2 bowls. So it starts at 0. Then where does, what do I graph for 3 pi over 4? Is it 3 pi over 4 comma 1, 0, or negative 1? 1. It goes to the high. What about 5 pi over 4? All right, now you're moving. And then 7 pi over 4? And then 9 pi over 4. Sine is 2 bowls. Now I'm also going to, show you something here. Like I said, I'm not going to hold you responsible for this, but it's actually not that big of a deal. Remember, these are pi over 2 away. Isabella, I'm going to put you on the spot. Is the y-axis a critical value? Is this pi over 2 away, yes or no? Oh, this is pi over 4 away. So the problem with this is, and this is the biggest problem with phase shifts, the y-axis is not a critical value. And this is off what usually messes people up when we have having to do 2 cycles. So what value is actually over here that's the next critical value? I'll give you a major hint. This is this far, so I'll go like this far. Correct. And then on the other side, you could probably fill out the rest. Negative pi over 4. It is a mirror image. It's just that the y-axis gets skipped as a critical value. And then I am doing this so that you understand the challenge of shifting right and left. It is a big challenge. And then here's the point of, okay, Isabel, I'm going to ask you now. This is the next critical value. Is it 1, 0, or negative 1? Keeping the flow going of the sine curve. Oh, see, if it was 0, then this would go straight across. But this has got to be like a curve. Yeah, this is the next low value. And then now that you got that, I'm sure you get the rest, right? So that is cycle number 2. This one, not so bad. Next one, I'm not even going to bother with it. It is and can be done, but the fractions get a little, overloaded. I just want you to be able to phase shift. Okay, so keeping going. What time do we get out of here? I never know the time. Is it 12:09? Oh, I can't remember. I remembered randomly. Okay, and then where are we at now? We're at Alex. Alex, why don't you fill them all out? What's the amplitude? What's the period? Think about that one for a second. This is funny. It's locked up everyone that's been asked this. What's this number right here? 2 pi over 1. So this is 1, so it's 2 pi over 1, which is just 2 pi. What's the phase shift? Left pi over 3. And then what's that minus 1 do? It is down 1. Now, Alex and everyone else, I'm going to handle that down 1 first. Then I'm going to go over and do my math off to the side. If you don't do this, you're more than likely not going to get a right answer. Your graph is going to be all jacked up. So I really implore you to put those critical values, cut them into fourths, then do the phase shift, then go to the x-axis. Otherwise, I think you're doomed. By the way, this is a cosine kid, so remember that. But here's what you're going to do. And I didn't really show this yesterday, although I did show kind of like this, but I'll show you how you start off with this graph. And I'm only going to do one phase shift. I'm sorry. I'm only going to do one cycle, so that's good enough. But the amplitude is 2 to negative 2, but everything gets moved down 1. So back to Muhammad, what's my new high point? If I'm from 2 to negative 2, but I go down 1, what's my new high point for the graph? So 2 to negative 2 is what the graph should have been, but it's moved down 1. What's the new high point? What's down 1 from 2? 1. And then the low point was going to be negative 2, but it moves down 1. So what's the new low point? Did you say something, Mohammed? Negative what? No, you're going down from -2. -3. And then everybody, you should do this. Move the x-axis down one in your mind and make this known that this is where the new zeros will be for the graph. So notice I asked in the last question, where does sine graph? Is it 0, high point, or low point? Well, now the dotted line is where the zeros, quote, belong. All right. And then you'll be all good. So the up down shift and the amplitude are all taken care of. Now I can move on to the x-axis values. Okay, we don't have to do this again. 0 to 2 pi, half of 2 pi is pi, half of pi is pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. You should have written those a lot in the beginning parts of your homework, so that should be all okay. All right, Alexander, if I'm going pi over 3 to the left, what do I have to do? Add or subtract pi over 3? Actually, I went the wrong way. Am I going pi over 3 to the left? What do I do with pi over 3? Do I add or subtract? That's like, I'm glad I re-asked that. All right, because now we got that correct. It's so weird. It says plus, sorry for that 3, but that means you subtract these x values before you put them on the thing. Alexander, just like, I think it was Aiden, did you have to do this math work twice, right? Alexander, what's the first one? Come on, that's easy. Okay, now be careful in the next one. What's the common denominator? This is why I write them. Just takes a little elbow grease, a little bit of writing. So I multiply this by 3. He said 6. Multiply this one by 2. Okay, then hopefully you can see that. What's 3 pi over 6 minus 2 pi over 6? Pi over 6. Moving on to Natalie, what's the common denominator for this one? So what do I have to multiply pi by? 3. So I have to multiply by 3 over 3. What's 3 pi over 3 minus pi over 3? And then this is reaffirmations, guys. This fraction work, this is why I've said this from the beginning of the year. People that can't do fractions really, 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 really struggle in CAT. And this is all this is fraction work. That is it. All right, Natalie, what's next? What's the common denominator between these two? 6, so I have to multiply by 3 and 2. And I got to squeeze that 2 in there. What's 9 pi over 6 minus 2 pi over 6? And possibly you might see a pattern develop, but this one's a little bit difficult. The best way to look at this is think about these all as over 6s. So let's start here. This is pi over 6. This is 4 pi over 6. This is 7 pi over 6. So what's this one unreduced? You're not far enough. These go up by 3 pi over 6. 10 pi over 6, which reduces to 5 pi over 3. And by the way, 3 pi over 6 is equal to 2 pi. These all went up by 3 pi over 6 each time using a common denominator. So that's the pattern that kind of develops because they are still pi over 2 away from each other. All right, and then something to understand, this is why this one's really bad as well as far as the x-axis. Pi over 3 is bigger than pi over 6. Would kind of like that reflected in this graph. I'm going to put it up here. I haven't really done this before, but I kind of like it. And then pi over 6 is smaller, meaning from the origin. So this distance should be shorter than that one by a half. I'm going to strangle myself with this cord. All right, move this a little bit. And then my next distance should be the same far away as these two are here. So I'll try to reflect that as well, but not getting a ruler out. I just want you to do the best you can to make this look pretty good and good spaced out. I'm not even going to talk about 2 cycles on this one. To go backwards, the backwards would be another over 6. Well, you subtract 3, negative 3 pi over 6 and then get a common denominator. But I'm done. Not doing it. Okay, then where are we at? We're at Sarah. Okay, now Sarah, it's not a big deal. Remember, this was cosine. How does cosine start? Don't answer it yet, but think about it yourself. Does it start at the high point or does it start at 0? There is no flipping on this. So negative pi over 3, where are you at? You at the high point, the 0, quote, or the low point? How does cosine start? The high point. So this is all you have to worry about. I'm going to just change the color to make this stick out more. It starts at the high point, and the high point now is 1 because of what we did with Muhammad there. And then what about pi? And again, the y-axis is skipped as a critical value. That stinks. There is no 0 here. So that's what can be tough. So Sarah, what's pi over 6, comma what? Careful. Don't say 0. So what's pi over 6, comma? Did you say negative 1? Nice. Went down 1. And then I think you could get it from here, flowing around. Be careful. I often get people that get these first 3, and then the next point they go back up here. All right. And they accidentally hit the 0 there. I see that all the time. It happens all the time. So just make sure you stay there and then a new high point. And then there's the cosine kid. Now, again, probably being too nice about, hey, let's do another cycle. All you'd have to do is subtract 3 pi over 6 from each of these and then do the math and get the common denominators. Let's just move on. Notice the range is from 1 to negative 3, kind of like what I mentioned yesterday. And then we'll only do this last one. It does put a lot together, and we're only going to do one period. All right? Now I'm even going to mention it. What time did you say we get out of here? Ah, okay. All right. So I know that they do this a lot. Does anyone know what the 1 actually is? 1 plus. What do you think the 1 is? Up 1. Thank you. This book does this all the time. As a matter of fact, I think every single question they put the upshift in front. I don't like it. I don't know why they do that. I guess you should be able to handle it, but okay. And then we have another problem. Do you see where that 2 is located? That 2 is located on the inside of the parentheses. You had something like this last semester. You had something like this last semester where you were forced to factor out that 2 so you could properly see the right left shift for what it really is. Now, this is what I often get. I get 2 possibilities. I get a lot of people that write, when I take a 2 out of this becomes 3 pi. Think about if it was 3 pi. What's 2 times 3 pi when you throw it back in there? That's a simple question. What's 2 times 3 pi? Is that 6 pi? No. So that's not 3 pi. It's 3 pi over, anyone? Anyone know what it is? I heard it. 4. I don't know what's going on. I think it's when my hand hits, then it just so annoying. I think I wish I had the option to turn the touch screen off, when I'm doing notes, because I don't need it. And then I think that's what's jacking up my pen. Okay, because of time, we're running low. So A is equal to 3, the amplitude. I think you can see now we have a new period value. It's 2 pi over 2, which is pi. Now, good, we get to break this down and make sure we get those correct values before we shift them. Which way are we phase shifting, right or left? Right. Good. Thank you. It ain't bad to be in tune here and answering what I ask. And then, of course, we already set up 1 even before. So just be careful on that 1 in front. The book does that, I think, in all of them. All right. And then Aiden, what's half of pi? Pi over 2. Is it really only 1 more minute? What time do we get out of here? Oh, it's 06. My pen stopped working. Hey, Aiden, what's half of pi over 2? Okay, then Aiden, we play the game. 1 pi over 4. Listen, Aiden, is this 2 pi over 4? So what's that one? And then is this 4 pi over 4? So then that's your discount double check. And then Robert, phase shift 3 pi over 4 right. What does that mean I have to do? Add or subtract? We're moving, man. You know what I'm going to do? I'm only going to put 1 of these because this is pretty easy. Most of these have and then I bet you we'll see a pattern develop. So, Robert, what's 0 plus 3 pi over 4? What's 3 pi over 4 plus 4 pi over 4? Over, which is? And then let's move to Skylar. What's 3 pi over 4 plus pi over 2, which has this common denominator? Go ahead. And then here's what we can do. Remember, this was 4 pi over 4. Pen's just being 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. I'll write the 7 pi over 4, and then the 6 pi over 4 is what? There we go. 3 pi over 2. We just have to reduce. So patterns can develop, and we can stop adding and just get the pattern. All right. And then here's what you want to do. If I make you do just one cycle, at least do me a favor. Do not put 3 pi over 4 right here. Okay, 3 pi over 4 is kind of a distance away from the origin. So at least give it some sort of distance that it is far away from, but I'm not going to get a ruler and measure your distances. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. Oh, and I forgot to do this. And I lost my distance, but I'll write this in a different color and go over them. I forgot to do my 3 to negative 3, but up 1. What's my new high value before you leave? What's my new high value? 4. What's my new low value? Negative 2, and then the dotted line's on 1. You can walk out as I finish this off. On these, I probably would mark all of the markings. 1 up means my new 0 is here. And then negative 2 is my new low value. This is a cosine kid, and it's positive. So it starts at its high value, 0, quote, quote, low value, 0, high value. And then there's your cosine kid. And I can shut down the movie. I am satisfied with what we got there. Oh, I don't like my graph, though. And kind of stuck on the screen and made me mess up my pen. Hey, have a good weekend. It's Wednesday. This is ridiculous. It's almost like a half spring break for you guys. Good stuff.